Hello friends, today we will look at Microsoft Agent Framework. We will look at what exactly is Microsoft Agent Framework? Why did Microsoft create it? And what happened to Semantic Kernel and AutoGen? Let's take a quick look at the history. And then we'll build our first AI agent in C#. Microsoft Agent Framework is a framework for building AI agents, multi-agent applications, and agentic workflows. But what does that actually mean? At the simplest level, an AI agent is software that can take a goal or instruction, use an AI model, and potentially use tools or other capabilities to accomplish that goal. An agent framework gives us the building blocks to create these applications. For example, we can create agents that interact with users, use tools and APIs, maintain state and memory, work together with other agents, and participate in more structured workflows. So instead of just making a call to an LLM and getting some text back, we can build an application where the AI can actually perform a task. To understand why Microsoft Agent Framework exists, we need to look at where it came from. There are two important names here: Semantic Kernel and AutoGen. Let's start with Semantic Kernel. Semantic Kernel became Microsoft's SDK for building AI-powered applications. For .NET developers, it was particularly interesting because it gave us familiar programming concepts around AI. Things like AI model integration, functions, memory, planning and orchestration, and a strong .NET ecosystem. So you could take a traditional .NET application and start adding AI capabilities to it. And as AI agents became more important, Semantic Kernel also developed its own agent capabilities and orchestration patterns. But there was another Microsoft project approaching agents from a different direction. And that's where AutoGen comes in. AutoGen came from Microsoft Research. Its focus was heavily around agents communicating and working together. Imagine we have a developer agent, a research agent, a testing agent, and a documentation agent. Instead of one AI doing everything, these agents can have different roles and collaborate. That made AutoGen particularly interesting for multi-agent systems. It helped developers experiment with agents that could communicate, collaborate, and delegate work. So we now had two Microsoft projects: Semantic Kernel coming strongly from the AI application and enterprise side, and AutoGen coming strongly from the agent and multi-agent side. And this is where Microsoft Agent Framework enters the story. Rather than thinking of it as Semantic Kernel got renamed, or AutoGen got renamed, a better way to think about it is Microsoft took the lessons and ideas from both projects and created their next-generation foundation for agentic AI. Microsoft's own documentation describes Agent Framework as the direct successor to Semantic Kernel and AutoGen. It combines AutoGen's agent abstractions and multi-agent patterns with Semantic Kernel's enterprise-oriented capabilities and adds workflows and newer state management capabilities. So the idea is now one framework for building AI agents, multi-agent systems, tools, and skills, memory and state, workflows, observability, and applications that can grow from a simple prototype into something much more substantial. And there's another important point. You don't have to jump straight into a complicated multi-agent system. You can start with one simple agent. And that's exactly what we're going to do. Let's quickly look at the main building blocks. First, we have the agent itself. This is the AI component that receives instructions and interacts with the model. Then we can give our agent tools. For example, check the weather, query my database, call this API, search these documents. Now our agent isn't limited to what the model already knows. We can also maintain state across interactions. So the agent can work with information from previous parts of a conversation or longer-running processes. Then we can have multiple agents. One could research. Another could write code. Another could review it. And another could test it. And finally, we have workflows. Instead of allowing everything to happen completely dynamically, we can explicitly define how different agents and components should work together. This is particularly useful when we need more control over a process. Let's actually build something. And we're going to start incredibly simple. No multi-agent architecture. No complicated workflow. No database. Just one .NET application. One AI model. One agent. And one very strange problem for our agent to solve. Before we jump into the code, we need to set up our AI model. For this example, we're going to use Azure AI Foundry. So, head over to Azure AI Foundry and sign in with your Azure account. If you already have a project, you can use that. If you don't, create a new project. Once the project is created, we'll need to deploy a model. Deploy the model you want to use and wait for the deployment to complete. Once it's ready, there are two things we need to take note of. First, the project endpoint. And second, the name of the model deployment. We're going to need both of these shortly. Later, we'll put them into our application's appsettings.json file. Let's create a simple .NET Console application. Our application needs a few things. We are going to install few packages. These include Azure AI projects, Azure Identity, Microsoft's Agents AI Foundry, environment variables, and JSON. At the top of our program we have our using statements. First, we're loading our configuration. This means we can keep things like our Azure endpoint and deployment name outside of our actual source code. Then we retrieve our endpoint. And our model deployment. So far, nothing particularly agentic. We're just setting up our configuration. Now things get interesting. This is the important part. Let's break this down. First, new AI project client. We're creating a client that connects our application to the Azure AI project. Then, new Azure CLI credential. This allows us to authenticate using our Azure CLI credentials. So if you've already logged in with AZ login, our application can use that identity. And this is useful during development because we're not hard-coding an API key into our application. Now look at this. AsAIAgent. This is where we turn our AI project client into an agent framework agent. And we're providing three important pieces of information. First, model deployment name. That's the model deployment we want the agent to use. Second, instructions. These are the instructions that define how our agent should behave. And third, name, hello agent. We're simply giving our agent a name. Finally, we actually give the agent something to do. And there we go. We've just created our first AI agent using Microsoft Agent Framework. It's not a multi-agent system. It doesn't have tools yet. It isn't using memory. But it is an actual agent abstraction that we can build on. So the basic flow is user input, AIAgent, instructions plus model, LLM, agent response. And here's the important part. This first example is intentionally simple. The real power comes when we start adding capabilities. We can give it search or retrieval capabilities. And then we can have multiple agents working together. Stay tuned, and in the next video, we're going to add more features to our agent. We'll give our agent tools. And that's when our AI agent starts becoming much more than a chatbot. If you enjoyed this video and learned something new, don't forget to like, subscribe, and click the bell icon to stay up to date with all my latest .NET and AI content.